Hi, I'm Cosmo, the nerdiest monkey from the Rio de la Plata, and welcome to LieLab. Over the next few minutes, I'm going to knock down 40 lies that school sold you as science. The atom doesn't spin, plants don't eat dirt. Einstein didn't win the Nobel for what you think he did, and you got Schrodinger's cat exactly backwards. The atom doesn't spin, and inside you lives something that isn't yours. It's not your fault. We were all taught the same wrong things. Science moved forward, the textbooks didn't. Subscribe, because if a monkey can read scientific papers, you can drop 40 myths at your next dinner party. Let's get started. You've told this one at parties. NASA spent millions inventing a pen that could write in zero gravity. The clever Russians just used a pencil. Complete lie. And one of the best ones out there. NASA didn't spend a single dollar. The space pen was developed independently by a businessman named Paul Fisher, using money from his own company, and only afterward did he offer it to NASA, which in 1967 bought 400 units for $2.39 each, with a volume discount. And the Soviets, they bought them too, 100 pens and 1,000 refills in February of 1969. Before that, both programs used pencils, and it was a serious problem. The tip breaks, and inside a pressurized capsule full of oxygen, graphite shavings float around, which conduct electricity, along with flammable dust, near delicate instruments. After the Apollo 1 fire, nobody wanted anything flammable on board. It wasn't waste versus ingenuity. It was one guy with an idea and two superpowers buying it from him. You're in the car, your dad takes a sharp turn, and you slam against the door. That's centrifugal force, he says, with the authority of a mechanic. False. And this one's going to sting. Centrifugal force doesn't exist as a real force. Nothing is pushing you outward. What's actually happening is that your body, obeying Newton's first law, wants to keep going straight. It's the car that's turning, and the door comes to meet you. The only real force at play is centripetal, pointing inward, the one the tires exert against the pavement. If that force disappears, say if there's ice, you don't fly outward around the curve. You go straight along the tangent, like a rock from a sling. In a tight turn at about 62 miles per hour, the tires have to generate an inward force equal to more than half the car's weight. All of that force pulls toward the center. None of it pulls outward. Physicists call the centrifugal effect a fictitious force. It only exists for someone who's spinning along with the system. Nothing is pulling you. You're the one who wanted to keep going straight. Your teacher watered the classroom plant and explained that the soil feeds it, that the roots suck up food. That's why you have to add fertilizer, which would be like the plant's stew. Poorly explained. 400 years ago, a Flemish scientist named Jan Baptista van Helmont planted a 5.5-pound willow tree in a pot with about 198 pounds of soil. He only gave it water. 5 years later, the willow weighed nearly 170 pounds, and the soil had lost barely 2 ounces. Less than a cookie. So where did all that wood come from? From the air. Plants build their bodies from carbon dioxide captured by their leaves and from water. The soil contributes minerals, which would be more like vitamins, not the main course. And here's the cherry on top. Van Helmont concluded that everything came from water. He got it wrong. It took another 150 years and Priestley and Ingenhouse to discover that the secret ingredient was in the air. That huge tree on the sidewalk is condensed air shaped like a tree. It's the whole package. Messy hair, tongue sticking out. Relativity, Nobel. All bundled together, all obvious. False. Einstein received the 1921 Nobel Prize in Physics for his explanation of the photoelectric effect. That phenomenon where light hits a metal and knocks electrons loose from it. And pay attention to the detail, because that prize actually went unawarded that year and wasn't handed out until 1922, once they finally made up their minds. Relativity, neither the special nor the general theory ever earned him a Nobel. Why not? Because at the time, the committee considered it too speculative and too philosophical, and there was political noise and prejudices of the era swirling around it. So they rewarded him for the safest item on his resume. The irony is delicious. That paper on the photoelectric effect, published in 1905, is one of the pillars of quantum physics. the very theory Einstein later despised and fought against his entire life. They gave him the prize for the sun he didn't want to acknowledge. You look at the cookie package and it says 130 calories per serving. You picture a tiny little flame, something insignificant. Miscounted by a factor of 1,000, a physical calorie is the energy needed to raise the temperature of 1 gram of water by 1 degree. A trifle. What actually shows up on food labels are kilocalories, 1,000 calories each, which means that serving of cookies actually has 130,000 calories in the physics sense, and your daily diet of 2,000 calories is really 2 million. With that much energy, you could raise the temperature of about 5.3 gallons of water from the tap all the way to boiling. The mistake dates back to the 19th century when the chemist Wilbur Atwater started writing calorie with a capital letter to tell them apart. Nobody respected the capital letter. That typographical slip is still confusing the entire planet. Your body isn't a little candle. It's a furnace. In biology class, they told you with a look of amazement. Human beings are the most complex creature on the planet, so the human genome must have around 100,000 genes. Some textbooks said 140,000, each one more complex than the last. All equally convinced. False, and by a ridiculous margin. When they finished reading the human genome, in 2003, only about 20,000 protein-coding genes turned up. 5 times fewer. It was so unexpected that the scientists working on the project had set up an internal betting pool with actual tickets to guess the final number. Almost nobody bet that low. And now for the part that stings. 20,000 is roughly the same number an earthworm has, and considerably fewer than a rice plant, which has around 35,000. Complexity isn't about how many genes you have, it's about how they combine, when they switch on and when they switch off. A single gene can produce several different proteins, depending on how it's read. You don't have more letters than rice does, you just have better spelling. You drew it 1,000 times, a little ball in the middle with 3 little rings around it and dots on them. A miniature solar system. They even used it as the logo for atomic energy. Lie. That model was proposed by Niels Bohr in 1913, and by 1926 it was already retired. Electrons don't travel in orbits. They exist in probability clouds called orbitals shaped like spheres, peanuts, or bow ties. An electron isn't in a place traveling around. It's spread across a region where it's likely to show up if you measure it. And here's something even crazier. If an atom were the size of a soccer stadium, the nucleus would be a grain of sand at the center of the field, and everything else would be empty space. You are quite literally 99.99999999996% well-organized nothing. The atom isn't a solar system, it's a cloud with rules. You inhale oxygen, you exhale carbon dioxide. End of story. That's how you wrote it next to the drawing of the lungs. False. And knowing this saves lives. The air you breathe out still has around 16% oxygen in it. It went in at 21 and comes out at 16. Your body only keeps about 1/5 of what enters it. It's a surprisingly inefficient engine. The carbon dioxide you breathe out is only about 4 or 5% of the total. And that's exactly why mouth-to-mouth resuscitation works. If you exhaled pure carbon dioxide, blowing air into someone who'd passed out wouldn't do a bit of good. What you're actually doing is giving them air with plenty of leftover oxygen to keep their brain running. That leftover oxygen also explains why a scuba tank doesn't last very long, and why on a submarine you have to scrub the air rather than manufacture it. You breathe the way you eat. You leave half of it on the plate. The image is universal. Those huge hourglass-shaped towers pumping out a thick gray cloud. Radiation, poison, apocalypse. Lie. What's coming out of there is water vapor. Evaporated water. They're cooling towers, and they have no contact whatsoever with the radioactive circuit. Identical towers exist at coal plants and sugar factories, and nobody's afraid of those. Now here's the part that stings. Radiation isn't a human invention. It's raining down on you all the time. You receive about 240 millirem a year just from natural sources, cosmic rays, radon from the ground, potassium from bananas, and from your own body. And here's something even more uncomfortable. Coal plants release more radioactive material into the environment than a nuclear plant does under normal operation, because coal naturally contains uranium and thorium, and the smokestack scatters it around. The white cloud is just hot water with bad PR. Your teacher said it fast just to move on. If you divide by 0, it tends toward infinity. And everyone wrote it down. Relieved? False. Dividing by 0 doesn't give you infinity. It gives you nothing. It's undefined, forbidden. The operation simply doesn't exist. Here's why. Dividing 10 by 2 asks how many 2's fit into 10. 5. Dividing 10 by 0 asks how many zeros fit into 10. You could stack up zeros until the heat death of the universe, and you'd never reach 10. There's no answer. And there's a sharper argument still. If you approach 0 from the positive side, the result shoots up toward positive infinity. If you approach it from the negative side, it plunges toward negative infinity. Two opposite answers to the same question. Mathematics, which hates contradiction, says enough and slams the door shut, and this breaks real things. In 1997, the US Navy cruiser USS Yorktown was left adrift for nearly 3 hours out at sea because a crew member entered a 0 into a database and the entire system crashed trying to divide by it. 0 isn't a small number, it's an abyss with rules. Green-gray with the hide of a giant lizard. That's how they looked in the poster, on the chalkboard, and in the movies. Backwards, or almost. Since 1996, when Sinosauropteryx turned up in China, fossils with feathers preserved down to the last detail have kept piling up. Today we know that a huge number of theropods, the group that includes Velociraptor and the ancestors of Tyrannosaurus, had feathers or filaments. The adult T-Rex probably had scales, but its family line came feathered right out of the factory. The most brutal example is Uteranus, a relative of T-Rex about 30 feet long and weighing roughly 3,300 pounds, covered in filaments. Picture a chicken the size of a city bus. And there's more. In some fossils, the melanosomes, the tiny pigment packets, were preserved, and by measuring their shape, scientists were able to reconstruct actual colors. Anchiornis was black and white with a reddish crest, a dinosaur that looked like a fighting rooster. Dinosaurs never fully went extinct. One of them sings to you at 6 in the morning. An earthquake hits Chile. You turn on the news and the anchor says it with a grave face. 7.2 on the Richter scale. Almost a lie. Seismologists haven't used the Richter scale in decades. Charles Richter created it in 1935, and it was designed for medium-sized earthquakes in Southern California, measured with one specific type of seismograph. It had a big flaw. It maxed out. Past a certain magnitude, wildly different earthquakes produced almost identical numbers. Since 1979, thanks to the work of Hanks and Kanamori, we use the moment magnitude scale instead, which calculates the actual energy released based on how much rock moved and how far it slipped. The media still say Richter out of habit, the way some people still say VCR. Here's a fact for your next barbecue. Each point on the scale multiplies the energy by 32. An 8 isn't just a little worse than a 7, it's 32 times worse. Two smiling guys next to a little wire model. Textbook photo, textbook caption. False twice over. First, they didn't discover DNA. It was isolated by the Swiss scientist Friedrich Miescher in 1869, almost a century earlier, while he was analyzing used hospital bandages. He called it nucline. Second, what Watson and Crick actually did in 1953 was propose the double helix structure, and crucial to that was photograph 51, an X-ray diffraction image taken in Rosalind Franklin's lab, which Morris Wilkins showed to Watson without her knowledge or permission. Franklin was no longer alive when the Nobel came around. In 1962, she died in 1958 at 37 years old, and Nobel rules don't allow posthumous awards. Watson, Crick, and Wilkins took it home. The double helix had 3 visible signatures and 1 uncredited photograph. It's the little arrow in the circuit diagram. It leaves the positive terminal of the battery, travels through the wire, lights the bulb, and returns to the negative terminal. backwards. What actually moves through a copper wire are electrons, and electrons carry a negative charge, so they travel from the negative terminal to the positive one. Exactly the opposite of the arrow. Why do we keep drawing it wrong? Blame Benjamin Franklin, who back around 1750 had to make a coin flip guess about which of the two charges was actually flowing, and he guessed wrong. By the time J.J. Thomson discovered the electron in 1897, there was already a century's worth of books, calculations, and conventions written down. Fixing it would have cost more than just living with the mistake, since the math works out the same either way. And one more bonus fact: electrons move incredibly slowly, just a fraction of an inch per second. What travels fast is the push, not the particle itself. The arrow has been pointing the wrong way since 1750, and nobody cares. People use it in the office, at the gym, and in motivational speeches. It's Darwin's law, survival of the strongest. Supply, and with the wrong signature attached too. The phrase survival of the fittest was actually written by the philosopher Herbert Spencer in 1864, 5 years after Darwin's book came out. Darwin only added it in the 5th edition, and somewhat reluctantly at that. But the real problem isn't the author. It's the translation. Fittest doesn't mean strongest or most muscular. It means whatever fits best into its environment, like a key that slides into a lock. The fittest one can be the tiniest, the one that eats garbage, the one that sleeps 18 hours a day, or the one that plays dead. The all-time champion of evolution doesn't have a single muscle. Bacteria have been winning for 3.5 billion years, and just in your gut alone, there are about 38 trillion of them living right now. The strongest doesn't win. Whoever fits best does. That cylinder of platinum and iridium sitting under 3 glass bell jars in a basement in Severus. The Big K, the original kilogram, the standard for every kilogram on Earth. Not anymore. On May 20th, 2019, it was retired, and it was a historic change. The problem was embarrassing. That cylinder, compared against its official copies over the course of the 20th century, had changed mass by about 50 millionths of an ounce. Lighter than a grain of sand. Nobody could say for sure whether it had gained or lost weight, because the kilogram was, by definition, itself. A standard that can't be weighed against anything else is a standard that ages in secret. Today, the kilogram is defined using Planck's constant, fixed at 6.62607. 0.15 times 10 to the negative 34th. It's measured with a device called a Kibble balance, which compares mass against electromagnetic forces. Now, the kilogram isn't sitting in a basement. It's written into the laws of the universe, and nobody can steal it. It's the most famous constant in the universe. The speed limit, the c in the equation, unmovable. Half true, and that other half changes everything. Light travels at about 186,282 miles per second in a vacuum. Only in a vacuum. When it enters a material, it slows down. In water, it drops to around 140,000 miles per second. In ordinary glass, to around 124,000. In diamond, to under 77,700. And that's exactly why it sparkles the way it does, because the light that enters gets stuck bouncing around inside before it can escape. Every rainbow from a prism, every pair of glasses, every lens in your phone exists because light slows down inside matter. Want the record? In 1999, the physicist Len Howe slowed a beam of light down to about 56 feet per second, slower than a bicycle. Light is extremely fast, except when you put something in its way. The legend is juicy. Alfred Nobel supposedly banned the mathematics prize because his wife was cheating on him with the mathematician Mendeleev. False from start to finish, and there's a giant hole in it. Alfred Nobel never married. He had no wife to cheat on him. The corrected version talks about a girlfriend instead. And there's no evidence of any romance with any mathematician either. The real explanation is boring and believable. Nobel was a practical chemist and inventor holding 355 patents, obsessed with things that materially improved people's lives. Physics, chemistry, medicine, literature, and peace. Pure mathematics just wasn't on his radar. Besides, a prestigious mathematics prize already existed, funded by King Oscar II of Sweden. Mathematicians do have their own prize, the Fields Medal, created in 1936 and awarded every 4 years, only to mathematicians under 40. Nobody stole his girlfriend, he just lacked the imagination. The postcard version is beautiful. Darwin arrives in the Galapagos, looks at the finches' beaks, the light bulb goes off, and he steps off the boat with the theory of evolution tucked under his arm. Almost a lie. Darwin didn't even properly note which island each bird came from. He barely cared about them. He mixed them up in his bags and had to ask other crew members for their labels just to reconstruct the puzzle. It was the ornithologist John Gould in London in 1837 who told him those odd-looking birds were all close relatives. The birds that actually changed his thinking were the mockingbirds, not the finches. And the book itself didn't come out until 1859. 24 years after the voyage, no light bulb, no epiphany, 2 decades of doubting, breeding pigeons, and putting it off, the whole Darwin's finches label is marketing. And it dates to 1936. They put the spotlight on the wrong bird. You've heard your whole life that wrinkles in the brain are a sign of intelligence, that studying fills your brain with new wrinkles, that a smooth brain would be a dumb brain. Backwards. The wrinkles don't appear or disappear based on what you study. They're all already there when you're born, with the main pattern formed as early as the 6th month of pregnancy. So what are they for? Pure moving day logistics? The cerebral cortex, which is where the interesting stuff happens, is a sheet only about 1/10 of an inch thick. If you stretched it out flat on a table, it would cover about 388 square inches, roughly the size of the large napkin, and that napkin has to fit inside a skull about the size of a grapefruit. The solution is to wrinkle it up. That way, twice the surface area fits into the same space. It's exactly what you do when you cram a t-shirt into a small suitcase. And there are extremely intelligent animals with completely smooth brains. Crows, for example, solve multi-step problems with ease. You're not smart because you have wrinkles. You have wrinkles because you didn't fit. You breathe oxygen. Plants make oxygen. A scuba tank has oxygen in it. School logic concludes that air is oxygen. Big lie? The air you're breathing right now is 78% nitrogen. Oxygen barely reaches 21%. After that, there's almost 1% argon, a noble gas nobody ever talks about. And only then, at 0.04%, does the famous carbon dioxide show up. Which means that out of every 5 breaths, 4 are of a gas your body doesn't even use. It goes in and comes right back out. Like the relative who shows up to the barbecue and doesn't talk to anyone. And yes, that nitrogen does matter. It's what dissolves into diverse blood and causes decompression sickness if they surface too fast. We live in a nitrogen atmosphere with a sprinkle of oxygen on top. We all know the scene. Fleming comes back from vacation in 1928, finds a mold growing on a forgotten petri dish, sees that it kills bacteria, shouts eureka, and penicillin is born. Half true. And it's missing the best part. Fleming really did see the phenomenon, published it in 1929, and then basically dropped it. He couldn't purify the substance, doubted its clinical usefulness, and moved on to other work. Penicillin sat sleeping in the scientific literature for 10 years. In 1939, at Oxford, Howard Florey and Ernst Chain dusted off the paper and started working like maniacs. They used hospital bedpans as culture vessels. In 1941, they tested the compound on a policeman named Albert Alexander, who improved miraculously until they ran out of the drug halfway through treatment. They even recovered some from his own urine to keep going. It wasn't enough. The 3 of them shared the Nobel Prize in 1945. The fame, not so much. Fleming opened the door. Others carried the truck in. Golden rule from your first year of school. Protractor 3 angles 180. Case closed, incomplete. That only holds true in Euclidean geometry, meaning on a flat sheet of paper. And you don't live on a flat sheet of paper. Try this. Stand at the North Pole, walk straight down to the equator, turn 90 degrees, walk a quarter of the way around the equator, turn another 90 degrees, and head back to the pole. You just drew a triangle with 3 right angles. That adds up to 270, and you didn't cheat at any point. In the 19th century, Lobachevsky, Bolyai, and Riemann proved that there are perfectly consistent geometries where the total comes out to more or less than 180. These came in handy for Einstein because space actually curves near masses. Your teacher wasn't lying, they just forgot to mention that the universe isn't a chalkboard. Here it is. Myth number 24. The cat in the box, alive and dead at the same time. And that tarot card conclusion you hear everywhere. Quantum physics proves that reality is created the moment you observe it. Backwards, literally. Erwin Schrodinger invented that cat in 1935 specifically to mock that interpretation. He was corresponding with Einstein, and both of them were uncomfortable with the Copenhagen school of thought. So he built a reductio ad absurdum. If a particle really is in two states at once until someone looks at it, he said, then let's connect that particle to a box with a cat inside, and let the cat's fate depend on the particle. Are you seriously telling me the cat is in two states at once? A cat halfway between two realities? Today people quote it like it's some kind of self-help manual. And no, observing in quantum physics doesn't mean looking with your eyes. It means physically interacting with the system. Schrodinger drew a cartoon, and the world framed it as a portrait. The story is golden. The bearded Russian falls asleep exhausted, dreams up the whole table, and wakes up to write it down in one go. Almost a lie. The story actually comes from a friend, the geologist Inostrancev, and it was published quite a while afterward. Mendeleev had been working obsessively with cardboard cards like he was playing solitaire, and his manuscripts from 1869 show crossed out lines, doubts, and hand corrections. But the most important thing school leaves out is something else entirely. Mendeleev ordered the elements by atomic weight, which produced strange inconsistencies that didn't quite add up. The true ordering by atomic number, meaning by the number of protons, was discovered by the young Henry Moseley in 1913. Moseley was 26 years old, and 2 years later he went off to fight in the First World War and never came back. Many believe it cost him a Nobel Prize. The table wasn't dreamed up. It was sweated over, and then someone else had to fix it. You lumped them in with bacteria, bugs that make you sick, microbes, microscopic living creatures. Half true, and it's an open, fascinating debate. A virus has no metabolism. It doesn't eat, doesn't breathe, doesn't produce energy, doesn't grow, doesn't divide. Outside a cell, it's an inert crystal. You could store one in a jar for years like it was table salt. It's a protein capsule with an instruction manual tucked inside. When it enters a cell, it hijacks that cell's machinery and forces it to churn out copies. A virus doesn't reproduce. It gets reproduced. Things got a lot more complicated in 2003 with the discovery of the mimivirus. So large, it was visible under an ordinary light microscope, carrying almost 1,000 genes, more than plenty of bacteria have. A virus is only alive when you lend it your body. It's biology's freeloading brother-in-law. Sounds like a trick. 0.9999 going on forever. It gets closer and closer to 1. Edges right up to it, but never quite touches it. Like Achilles and the tortoise. False. It's equal to 1. Not similar, not approximately equal. Equal, the same number written two different ways, like 1/2 and 0.5. Here's the pocket-sized proof. We all accept that 1/3 equals 0.333. Repeating forever. Multiply both sides by 3. 3/3 equals 1. And 0.333 repeating times 3 equals 0.999 repeating. Done? Here's another proof. If two numbers are different, there's always another number that fits between them. Name a single one that sits between 0.999 repeating and 1. You can't, because there's no room, no gap. And if there's nothing in between, they're the same point on the number line. The discomfort isn't in the math. It's in your intuition, which is an amateur here. We've all seen how South America fits into Africa like a puzzle piece. School tells it like an obvious stroke of genius that Alfred Wegener noticed it and everyone applauded. Almost a lie. Wegener published his idea in 1912 and nobody applauded. They tore him apart. They called him an amateur because he was a meteorologist, not a geologist. At a conference of petroleum geologists in 1926, they practically humiliated him. His big problem: he couldn't explain the engine behind it. He didn't know what force could push entire continents around the planet. Wegener went on an expedition to Greenland in 1930 and never came back. At 50 years old, his theory still discredited. It wasn't until the 1960s, with the discovery of seafloor spreading and the magnetic stripes across the Atlantic floor, that the mechanism was finally understood, and he was proven right. He was right and never got to know it. Science does apologize, it just shows up late. Every textbook shows the same thing: a flattened oval with the sun shoved off to one side, tucked right near the tip. And so you naturally conclude the obvious, that there's a time of year when we're close and a time when we're far, badly drawn. Yes, it's an ellipse. Kepler was right about that, but its eccentricity is 0.0167, essentially zero. If you drew the real orbit on a sheet of paper, you wouldn't be able to tell it apart from a perfect circle with the naked eye. Not even with a ruler. The numbers. At its closest point, we're about 91.4 million miles from the sun. At its farthest, about 94.5 million. A difference of barely 3%. And here's the knockout. If you took a compass and drew a perfect circle about 4 inches across, and next to it drew Earth's real orbit at the same scale, the maximum difference between the two shapes would be less than about 0.04 of an inch. Nobody can see that. The oval in the textbook is a teaching lie that overstayed its welcome. Newton's third law: every action has an equal and opposite reaction. And that's when the class smart aleck jumps in. So if they cancel out, nothing could ever move. Misunderstood. The two forces never cancel out because they don't act on the same object. That's the entire trick, and nobody ever explains it. When a horse pulls a cart, the cart pulls back on the horse with the same amount of force. But one force acts on the cart, and the other acts on the horse. To figure out whether the cart moves, you only look at the forces acting on the cart, and the reaction force isn't one of them. The horse moves forward because it pushes the ground backward with its legs, and the ground pushes it forward in return. It's the ground that moves you, always. That's exactly why a rocket works in a vacuum. It doesn't need to push against air. It pushes against its own expelled fuel. And when you jump, you push the Earth downward with exactly the same force it pushes you upward with. The Earth does move. It's just that it weighs about 1.3 times 10 to the 25th pounds. So it shifts by a distance far smaller than the diameter of a proton. They never cancel out. They're just sitting in different pockets. Here it is, the one I promised, the most recited sentence in the history of school biology. We all know it, we all wrote it on the test. Nobody ever questioned it. The mitochondria is the powerhouse of the cell. Incomplete and in a spectacular way. Yes, it produces energy, but saying only that is like describing your mom by saying she makes dinner. The mitochondria also regulates calcium, produces heat, manufactures hormones, sends signals to the immune system, and decides when a cell has finished its life cycle and needs to retire. It has more than 1,000 different proteins working inside it. And now for what school never told you. About 1.5 billion years ago, the mitochondria was a free-living bacterium that another cell swallowed and never digested. They ended up living together permanently. That's why, to this day, it still has its own DNA, 37 genes of its own, separate from yours. That DNA came from your mom. Only your mom. It's passed down mother to mother, unbroken, for thousands of years. It's not a battery. It's a tenant who moved in with its own furniture. Negative 459.67 degrees Fahrenheit. The final cold. Atoms motionless, frozen, dead still. That's how they told it to you. Incomplete, and quantum physics gets the last laugh. Even at absolute zero, an irreducible tremor remains, called zero-point energy. Heisenberg's uncertainty principle forbids anything else. If a particle were completely still at an exact location, you'd know both its position and its velocity with perfect precision at the same time. And the universe simply doesn't allow that. That's why liquid helium at normal pressure never freezes, not even at 0 Kelvin. That tiny residual tremor is enough to keep it liquid. On top of that, absolute zero is unreachable by thermodynamic definition. you can get closer. The current record sits at about 38 trillionths of a degree Fahrenheit above absolute zero, achieved in 2021 in a free-fall drop tower in Bremen. The universe has insomnia. Even in the coldest cold, it never quite stays still. Someone always shows up with a smug little smile and asks, if we came from monkeys, where's the missing link? A lie from the start. The concept of a link comes from an old dead idea, the great chain of being, where life was pictured as a ladder with humans on the top rung. Evolution isn't a ladder, it's a tangled bush with branches crossing every which way, and transitional fossils are everywhere. Archaeopteryx, half dinosaur, half bird. Ambulocetus, the walking whale with legs. And the most elegant of them all, Tiktaalik, found in the Canadian Arctic in 2004 after a team predicted the exact age of the rock layer where it should be found. A fish with a neck, elbows, and wrists. Every time you find an intermediate fossil, you create two brand new gaps, one on each side. The question never actually ends. The link isn't missing. The chain is missing because there was never a chain to begin with. It's one of the most beautiful things they tell you in class. Pi has infinite non-repeating decimals, so somewhere in there is your birth date, your ID number, and the entire Bible encoded. Lie, or rather, nobody actually knows. Just because a number is infinite and non-repeating doesn't guarantee it contains every possible sequence. Take a look at this number, 0.1, 01, 001, 0001, 00001, and so on. Infinite. The pattern never repeats, and yet a 7 will never appear in it. Not for all eternity. What would actually be needed is for pi to be what mathematicians call a normal number, one where every digit and every combination of digits shows up with the same frequency. It's strongly suspected that pi is normal. More than 300 trillion decimal digits have been calculated, and it behaves as if it were, but proven zero. It remains one of math's open problems. Your phone number is probably in there. Probably isn't the same thing as definitely. You wrote it on the test and got it right. Absolute zero is 0 degrees Kelvin. Wrong. And this one's a freebie. There's no such thing as degrees Kelvin. You just say Kelvin, plain and simple. 0 Kelvin, 300 Kelvin. The unit name is lowercase, and its symbol, the letter K alone, is capitalized because it comes from a surname. Same thing happens with Watt and with Newton. Why no degrees? Because the Kelvin scale is absolute. It has no arbitrary reference points the way Celsius does, which picked freezing water and boiling water. Two pretty planet Earth-specific events. Kelvin starts at true zero, the point where nothing can possibly be colder. In 1967, the International Conference on Weights and Measures officially dropped the word degree from the scale. 59 years later, your physics textbook still hasn't gotten the memo. Celsius has degrees, Kelvin has dignity. The analogy is so convenient they named the whole thing after it. Glass lets light in, doesn't let heat out, and everything inside cooks. The atmosphere supposedly does the same thing with carbon dioxide. Almost a lie. And it's a terrible analogy. A real greenhouse heats up, mainly because the glass stops warm air from escaping upward. It blocks convection, not radiation. It's a jacket, not a light trap. The physicist Robert Wood proved this in 1909. He built two identical boxes, one with an ordinary glass roof and one with a rock salt roof, a transparent material that does let infrared light through. They heated up to practically the same temperature. So much for the magic glass theory. The atmosphere, on the other hand, really does work through radiation. Greenhouse gases absorb the infrared radiation rising from the ground and re-emit it in every direction, including back down toward the surface. Same name, completely different mechanism. The christening was rushed. It was laminated and hanging on the wall. Observation, hypothesis, experiment, conclusion. Like a recipe for meatloaf. Follow the steps and out comes science. False. No scientist actually works that way, and there is no single scientific method. An astronomer can't run experiments on galaxies. A paleontologist can't repeat the Jurassic. An epidemiologist spends their whole career working with data about things that already happened. Real science is a beautiful mess of hunches, mistakes, calculations, arguments, coincidences, and ego battles at conferences. The philosopher Paul Feyerabend wrote an entire book in 1975 to argue that the only rule that always holds is that any given rule eventually gets broken. And the whole enterprise still works because what actually holds the building up isn't the steps, it's cross-checking. Someone else has to be able to review your work and challenge it. Science isn't a recipe, it's an argument with rules of etiquette. Someone in class raises their hand and drops the line that ruins any teacher's afternoon. Evolution is just a theory, as if to say some loose idea, a hunch, a dinner table guess. False. And false because of a cultural translation problem. On the street, theory means a guess. In science, theory is the highest rank you can reach. It's an explanatory framework that has survived decades of attempts to tear it down, that predicts things you haven't seen yet and gets them right. Think of it this way. A hypothesis is a sketch on a napkin. A theory is the finished bridge with trucks driving over it every single day. The theory of evolution has 167 years of trucks behind it. General relativity has withstood over 100 years of attempted demolitions and still checks out, with a precision of 1 part in 100 billion. Germ theory is also just a theory, and that's exactly why you wash your hands. In science, a theory isn't the doubt, it's the diploma. They painted it for you like a military hierarchy. Hypothesis is a private, theory is a sergeant, and above everything sits the law, capital L, the final truth. False. There's no promotion ladder. A theory never turns into a law over time, because they're fundamentally different kinds of things. A law describes what happens, usually with a short equation. Newton's law of gravitation tells you exactly how strongly two masses attract each other. Perfect. But it doesn't explain a single thing about why. A theory explains the why. General relativity tells you that mass warps space and time, and that gravity is that very warping. It's infinitely deeper than the law, and it even corrects it. Without it, your phone's GPS would be off by about 6.2 miles every single day. The law is the photo of the crash. The theory is the video with audio. We'll close with the patron saint of the classroom, the man of reason, classical physics, calculus, and British restraint. Magnificent lie. Isaac Newton wrote more words about alchemy and theology than about physics and mathematics combined. He spent decades locked away with furnaces, hunting for the philosopher's stone and a substance he called philosophical mercury. And he filled hundreds of thousands of pages with theological ideas that strayed from official doctrine. Something that, in the England of his time, could have cost him his entire career. His secret papers were auctioned off in 1936, and a good portion of them were bought by the economist John Maynard Keynes, who, after reading them, wrote a crushing line. Newton wasn't the first of the age of reason. He was the last of the magicians, and there's a sad possibility here too. Analysis of his hair showed traces of mercury, and his tremors and paranoia in 1693 may have come from that. The father of modern physics was hunting for gold using spells, and he still discovered gravity for you anyway. There you have it. The 40 lies they taught you, in a white lab coat, scattered on the floor now like crushed chalk. Leave a like, subscribe, and tell me in the comments which one was hardest for you to let go of.